The equation of a curve is y is equals to 3x squared minus 4x plus 1. A. Find the gradient function of the curve and its value when x is equals to 3. B. Determine 1. The equation of the tangent to the curve at point 2, 5. 2. The angle which the tangent to the curve at point 2, 5 makes with the horizontal. 3. The equation of the line through point 2, 5 which is perpendicular to the tangent in B1. The curve y is equals to ax cubed minus 3x squared minus 2x plus 1 has a gradient of 7 when x is equals to 1. Find the value of a. Find the equation of the tangent to the curve y is equals to brackets x squared plus 1 into x minus 2 when x is equals to 2. The distance from a fixed point of a particle in motion at any time t seconds is given by s is equals to t cubed minus 5 over 2 t squared plus t plus 5 meters. Find its a. Acceleration after t seconds, b. Velocity when acceleration is 0. A curve is given by the equation y is equals to 5x cubed minus 7x squared plus 3x plus 2. Find the gradient of the curve at x is equals to 1. B. The equation of the tangent to the curve at the point 1, 3. The displacement x meters of a particle after t seconds is given by x is equals to t cubed minus 2t squared plus 6, where t is greater than 0. A. Calculate the velocity of the particle m when t is equals to 2 seconds. B. When the velocity of the particle is 0, calculate its 1. Displacement, 2. Acceleration. Given that curve y is equals to 2x cubed plus a half x squared minus 4x plus 1, find 1. The gradient of the curve at 1, negative a half. 2. Equation of the tangent to the curve at 1, negative a half. The displacement s meters of a particle moving along a straight line after t seconds is given by s is equals 3 over 2t squared minus 2t cubed. A. Find its initial velocity. B. Calculate 1. The time when the particle was momentarily at rest. 2. Its displacement by the time it came to rest momentarily. C. Calculate the maximum speed attained. Find the coordinates of the turning points of the curve whose equation is y is equals to 6 plus 2x minus 4x squared. A1. Find the coordinates of the stationary points on the curve y is equals to x cubed minus 3x plus 2. A2. For each stationary point, determine whether it's a minimum or a maximum. B. Sketch the graph of the function y is equals to x cubed minus 3x plus 2. The velocity v m per second of a moving body at a time t seconds is given by b is equals to 5t squared minus 12t plus 7. Calculate the acceleration when t is equals to 2 seconds. A stone is thrown vertically upwards from a point O. After t seconds, the stone is s meters from O. Given that s is equals to 29.4t minus 4.9t squared, Find the maximum height reached by the stone. A curve is represented by the function y is equals to a third x cubed plus x squared minus 3x plus 2. A. Find dy over dx. B. Determine the values of y at the turning points of the curve. C. In the space provided below, sketch the curve y is equals to a third x cubed plus x squared minus 3x plus 2. A particle moves along a straight line such that its displacement s meters from a given point is s is equals to t cubed minus 5t squared plus 3t plus 4, where t is time in seconds. Find A. The displacement of the particle at t is equals to 5. B. The velocity of the particle when t is equals to 5. C. The value of t when the particle is momentarily at rest. D. The acceleration of the particle when t is equals to 2. The gradient of the tangent to the curve y is equals to ax cubed plus bx at point 1, 1 is negative 5. Calculate the values of a and b. The sum of two numbers, x and y, is 40. Write down an expression in terms of x for the sum of the squares of the two numbers. Hence, determine the minimum value of x squared plus y squared. The distance s meters from a fixed point O covered by a particle after t seconds is given by the equation s is equals to t cubed minus 6t squared plus 9t plus 5. A. Calculate the gradient of the curve at t is equals to 0.5 seconds. B. Determine the value of s at the maximum and the minimum turning points of the curve. C. Sketch the curve of s is equals to t cubed minus 6t squared plus 9t plus 5. A rectangular box open at the top has a square base. The internal side of the base is x centimeters long and the total internal surface area of the box is 432 centimeters squared. Expressed in terms of x, 1. The internal height h of the box. 2. The internal volume v of the box. B. Find 1. The value of x for which the volume v is maximum. B2. The maximum internal volume of the box. The displacement s of a moving particle after t seconds is given by s is equals to 2t cubed minus 5t squared plus 4t plus 2. Determine A. The velocity of the particle when t is equals to 3 seconds. B. The value of t when the particle is momentarily at rest. C. The displacement when the particle is momentarily at rest. D. The acceleration of the particle when t is equals to 3 seconds. The equation of a curve is y is equals to 2x cubed plus 3x squared. Find 1. The x-intercept, 2. The y-intercept. B1. Determine the stationary points of the curve. B2. For each point in B1 above, determine whether it is a maximum or minimum. C. Sketch the curve. The acceleration of a body moving along a straight line is 4 minus t meters per second squared, and its velocity is v meters per second after t seconds. A1. If the initial velocity of the body is 3 meters per second, express the velocity v in terms of t. A2. Find the velocity of the body after 2 seconds. B1. Calculate 1. The time taken to attain maximum velocity. B2. The distance covered by the body to attain the maximum velocity. The displacement s meters of a moving particle from point O after t seconds is given by S is equals to t cubed minus 5t squared plus 3t plus 10. A. Find S when t is equals to 2. B. Determine 1. The velocity of the particle in t is equals to 5 seconds. Determine 2. The value of t when the particle is momentarily at rest. Find the time when the velocity of the particle is maximum. The equation of a curve is given by y is equals to x cubed minus 4x squared minus 3x. A. Find the value of y when x is equals to negative 1. B. Determine the stationary points of the curve. C. Find the equation of the normal to the curve at x is equals to 1. The gradient of the curve y is equals to 2x cubed minus 9x squared plus px minus 1 at x is equals to 4 is 36. A. Find 1. The value of p. A. 2. The equation of the tangent to the curve at x is equals to 0.5. B. Find the coordinates of the turning points of the curve. The equation of a curve is given by y is equals to 2x cubed minus 9 over 2x squared minus 15x plus 3. Find 1. The value of y when x is equals to 2. The equation of the tangent to the curve at x is equals to 2. Determine the turning points of the curve. The equation of a curve is given by y is equals to a third x cubed minus 4x plus 5. Determine A, the value of y when x is equals to 3. B, the gradient of the curve at x is equals to 3. C, the turning points of the curve and their nature. The equation of a curve is y is equals to x cubed plus x squared minus x minus 1. Find the stationary points of the curve, the nature of the stationary points in A1 above. B. Determine the equation of the tangent to the curve at x is equals to 1. B2. The equation of the normal to the curve at x is equals to 1. Find the coordinates of the turning points of the curve y is equals to x squared minus 14x plus 10. The displacement s meters of a moving particle after t seconds is given by s is equals to 2 over 3 t cubed minus 7 over 2 t squared minus t plus 8. Determine the A. Velocity of the particle when t is equals to 5. B. Time t seconds when the particle is momentarily at rest. C. Displacement s meters when the particle is momentarily at rest. D. Acceleration of the particle when t is equals to 4 seconds. A curve is given by y is equals to 2 cubed minus 3x squared minus 12x plus 12. A. Find the gradient of the function of the curve. B. Determine the equation of the normal to the curve at point 1, negative 1 in the form of y is equals to mx plus c, where m and c are constants. The equation of a curve is given as y is equals to a third x cubed minus a half x squared minus 2x minus a third. A. Find 1. The value of y when x is equals to negative 2. 2. The equation of the tangent to the curve at x is equals to negative 2. B. Determine the coordinates of the turning points of the curve. A supermarket sold 530 packets of milk daily when the price was 50 shillings per packet. Whenever the price per packet was increased by 4 shillings, the number of packets sold daily decreased by 20. If n represents the number of times the price was increased, A. Write an expression in terms of n for 1. The price of a packet of milk after the price was increased. 2. The number of packets of milk sold after the price was increased. 3. The total sales in simplified expanded form after the price of a packet of milk was increased. B. Determine 1. The number of times the price was increased to attain maximum sales. 2. The price of a packet of milk for maximum sales. 3. The maximum sales. The equation of a curve is given by y is equal to 3x squared minus 2x. Determine the equation of a normal to the curve at x is equal to 2. The displacement x meters of a particle moving along a straight line after t seconds is given by x is equal to t cubed over 3 minus 3t squared plus 9. A. Determine 1. The value of t when the particle is momentarily at rest. 2. The value of the displacement x meters by the time the particle comes to rest. B. Determine the values of t when the velocity of the particle is negative 5 meters per second. C. Determine the acceleration for the particle at t is equals to 2 seconds.